And good morning, everybody. Welcome into week number 3 here of our Wednesday morning class. Appreciate everybody being here. Kind of a rainy, gloomy day over here in Taylor's. I guess we'll get through this rain here before long. At least it's not snowing, no ice on the ground. That's good. So hope everybody's doing all right today. Right before class, I looked in Blackboard to double check and see how we were doing on getting all of our work submitted in this class. And you guys have done great. Out of all of our assignments last week, I only saw one missing forum post. Everybody else got everything in, and I appreciate that. The more work you can do in Python and programming, the better. That's how you're going to get good at this. So we want to keep getting our assignments in, especially our labs, get all that stuff done. So I'm gonna go ahead and share out my screen here and get started on things because we have a long class today. And well, let's see here. There it is. It took a while to come up this time. Let me make a couple of adjustments. Put that up there. Bring this up. Get rid of that. Okay. So now we're down into week number 3 of our class. And I wanted to go ahead and warn you that today's class will probably run longer than an hour and a half. That will also be the case next week. These are big chapters. These are the foundation chapters for learning Python. And as the title of this chapter says, how to code control statements, that is huge. If you do not understand control statements, you will not be able to program. So yesterday's class ran about an hour and 50 minutes. We did get to talking about a few things. Maybe we won't be quite that long today, but I looked at last semester and we ran over 2 hours on this unit. So just realize Unit 3 and Unit 4 are big chapters because we got a lot of details to get into. And so if you have to leave before we get done, I understand. But please come back and watch the video because hopefully I'm giving you some insight into some of these structures and statements that we need to learn, and I'll help you pick this stuff up. So this week we got to really bear down on chapter 3, study chapter 3. This is one you're going to have to read over a couple of times to really absorb. We have one discussion post this week, 3 labs. These labs are going to be harder than last week's labs. Do not be surprised about that. And you have one quiz to turn in. And this particular class, your class, is doing a really good job on the quizzes. And so let me address a couple of things that have happened since last week. All of this week's activities have to be in by Sunday, which is the end of the month, January 31st. Can you believe that January's almost over? So let's get back to quizzes. I want to talk about a couple of problems. This week, I had 3 students in our 4 classes. 3 students find mistakes. There was one mistake in the Unit 2 quiz and one mistake in the Unit 3 quiz. And I appreciate you guys letting me know if you see something that doesn't look right, because the chances are that it's probably not right. You're probably correct and I'm probably wrong. Understand, and I'm just full disclosure, the quiz questions came from the publisher. I did not write those questions. I wish I was that smart. But so they could have typos in them that I have not uncovered yet. We had 2 sections last semester, and they did not uncover any of these errors. So that's kind of interesting. But in both cases, the two questions that were wrong, students told me there was a problem. They didn't actually come up with the right solution, but there was a problem. So I had to go in and make a correction. So try to fix that for you guys and regrade your regrade your quizzes. I don't think either one of them affected anybody's grade, but could have. The problem with doing the quizzes the way we're doing them, where I give you 3 times to make 100, is if there's a question that has a wrong correct answer and the key is marked as correct, we're not learning anything. And I want to protect against that as well as I can. So yeah, if you see something that doesn't make sense, certainly let me know. I hope that this is just a little blip in the radar and not something we're going to run into each week. Now to the labs, let me address a couple of things on that. I have not graded the Unit 2 labs that you turned in on Sunday. I'll get to those probably tomorrow and Friday. So let me go all the way back to unit number 1 and lab 1-2 first. And both situations I want to talk to you about deal with reading the instructions. When it comes to doing labs in this class, you actually have 2 sets of instructions. You have some instructions in Blackboard, which basically deal with how to submit the lab, what I want you to turn into Blackboard to get your grade. And then in the textbook, you got a whole bunch of instructions on how to do the lab. And what happened in Unit 1, and I know it was early in the course, several students in each class did not follow the submission instructions in Blackboard and were turning in the wrong thing. For example, the 1-2 lab said explicitly in the instructions to take a screenshot of idle running the source code, compiling the source code, and to take a screenshot of the interactive shell running or compiling the source code, and you enter in data and that kind of stuff. And I'm paraphrasing, needless to say, but it said to take a screenshot of idle running the script, the source code. What was happening is many students were sending me the source code with no evidence that it ran. Other students were running it in a console in Windows 10, which is great to do that. I do that, but that was not what the submission instructions were. If there's one thing that we have to do early on in this class is follow directions. And I know you guys want to follow directions. So that is what's going on there. And we want to make sure that you turn in exactly what I want you to turn in. In lab 1-3, which is very typical of what we're going to see the rest of the way, is I ask you to attach the PY file that you worked on in lab 1-3. And I got all kinds of stuff turned in. And in many cases, there was no .py file. So be very careful to read the instructions in Blackboard. Turn in exactly what I'm asking for so that we don't have any disappointments on that in the future. Want to call to your attention, it's coming up next week, unit test number 1, units 1, 2, and 3. You'll have 3 days to take that test, Monday, Tuesday, and Wednesday of that week, week 4 next week. So realize that's coming up. You can go ahead and start reviewing for that if you have some extra time. There is a review sheet in Blackboard. My review sheets on the unit tests are word lists of words that are tested in the unit test. So it does narrow the scope of what you have to review possibly and help you focus on exactly what's going to be on the test. But realize we have a Monday, a Tuesday, and a Wednesday that the tests will be open, and that's consistent throughout the whole course. So are there any questions on what's coming up? Is that as far as that's concerned? Let me take a look here. Okay. So does everybody see my screen okay? I haven't heard anybody yell at anything. So you seeing it all right?
Yes, I can see it fine.
Good. Okay. The reason I'm asking is I am not seeing something on my end. So I'm going to stop the share for a second. I want to make an adjustment, which helps me. Okay. And I'm going to go back to sharing it. Oh, there we go. Now it's looking like it's supposed to. I put my camera right up under my camera here. So when I look at it, I'm kind of looking at the camera. I'm trying to give you a little more eye contact. It's one of my secrets. I know it's annoying when I never look at you. So that's what I'm trying to do there. Let's go ahead and get into unit number 3, how to code control statements. This is true of any programming language that's worth anything. And we've got to have control statements. And some of you guys in this class have already learned some programming from other classes, maybe a C# class or a Java class or something you've done outside of Greenville Tech. And you're going to see that there are a lot of similarities and there are a lot of differences when we get into control statements. But at the end of the day, we have to understand these control statements because control statements control the logic of the program. Without control statements, we can't get from point A to point B. So that's why they're critical, and that's why we take a little extra time on this. So in Unit 3, we're going to learn the differences between a Boolean variable and a Boolean expression. And I know students break out in a sweat when I start talking about Booleans. But if you've done any programming, you've seen this. This is very consistent with other languages, and Booleans are not that hard. Don't overthink it. But it is similar to math, but not the same as math. It has an order of precedence. So we got to understand which comes first, which comes second. We can control that order of precedence with the parentheses. So if we want a Boolean to do something unusual that it's not defaulting to, we can do that. Also, another thing that is very important when we're dealing with Boolean expressions is to make sure that we control case. Remember, we have 26 uppercase letters, 26 lowercase letters. We have some numbers from time to time. But the fact of the matter is we're going to need to have string comparison to get these Booleans to really do their thing for the most part. So we have to be careful about that. So we're going to learn a lot about using two methods, lower method and upper method. Now, a sidebar here that is not really dealt with much in this chapter, and I'm hoping that this will help you understand a little bit because it's something that I had to work on and I'm still working on in my programming because I want to be able to, because I'm a teacher, certainly I want to be able to speak knowledgeably and use the right words at the right time. But when it comes to methods, they look just like functions. I mean, they appear just like functions in the code. So it's the name of the method and then parens, and you have parameters inside the parens, just like a function. There's one difference, and I've looked and researched this to make sure I say this right, but a function deals with data. When you are running a print function or an input function, you are changing data, okay? And here's the subtle difference. A method is all about dealing with object-oriented programming, and methods work on objects as compared to data, okay? So when we are doing something with an object, okay, then we will use methods. And when we're doing something with data, we're going to be doing functions. So as we go through this, and please let me know if you discover something different. But as we go through the course, kind of be aware of the difference. It is subtle. It is very subtle, and it's not going to be something that jumps in your your brain there really easy. So you're going to find that I'll screw up too. I'll call a method a function and a function a method at least 100 times. I'm going to try to do better. but understand that they are actually two different things. So we need to understand the lower method and the upper method that change the case of whatever it is between the parentheses. There's only one parameter in those methods, and it is something that we want to change, an object that we want to change from upper to lower. I know that's hard to understand. Okay, so something that is easy to understand is an if statement. This is our first control statement, our first control structure. It's going to have one clause in it, an if clause. It could have else if clauses, one or more, and it could have an else clause. If you're going to have an else if clause, you're going to have an else clause, okay? But you got to have an if clause. Then and as we look at the structure, you'll see what I'm talking about. Other options, think of an if statement as a branch with a bunch of options, okay? And some people call this a selection structure. That's okay. A decision structure. That's okay. And in any decision, you have one or two or three options. Well, that's the case with an if statement. You're going to have options that you want to deal with, selections that you want to deal with. So we need to understand how that works. The next thing is a repetitive structure, something that works over and over and over while a situation exists. And, we do repetitive structures all day long. I want to paint this wall right here bright red. So I start stroking, and I have to stroke and stroke repetitive as I'm putting paint on the wall until the whole wall is finished. And once the wall is finished, then I'm done. Okay. That is a repetitive structure. So we program that with a loop, and it could be a while loop or it could be a for loop. A while loop is very popular. Both of these are very popular and very important. A while loop does a repetition of commands while a test is positive, while it's true, okay? A for loop does a loop for a certain number of times and then it stops, okay? So we'll see how to control those and how to write those, and you're going to see them for the remainder of the course. So it's very important that we understand loops. But those are the main control things. We have decision statements, if statements, and then we have repetitive statements like while or for loops. We have three really big statements or structures we've got to understand. We also need, when we're talking about loops, we have to understand break and continue statements. And a break statement does exactly what you would think. It breaks out of the loop. Continue statement goes back to the top of the loop. So we'll see how to use those to add a little more complexity to the loops that we deal with. Now, yesterday in class, I got off on a tangent I probably shouldn't have about pseudocode. So I'm going to try not to do that today. But we also have mentions of and several pages on pseudocode in this chapter. And we don't talk about pseudocode much in this course. I'm not a huge fan of pseudocode. I think it is a personal decision how you map out or structure your design. Pseudocode is the industry standard, okay? So to get control statements to do what you want, it is very helpful to get a piece of paper and a pencil and start writing out what you want the program to do, and then lay it into control statements. Map it is the best way to think about it. Map it in pseudocode so that your logic is correct. And that's when you're designing a program. We're going to design some in this course, but we're not going to do a wholesale project. I wish we had time to do that. If we ever get a Python 2, maybe we'll have a project in that class. We do a lot of design in the PHP course, if that's ever going to be offered again. I hope it will. We do a lot of design in the second C# course, the second Java course, but we don't do much design in this course. We'll do some, okay, but not a lot. We can use pseudocode to help us with that design. So let's dig in here. As I said, control statements give Python the ability to control the execution of a program. Think of this as the transmission, the steps that we have to go through. It's like the transmission in the car. When you go from stop to 55 miles an hour, you go through several steps. And those are all control statements. These statements include if statements and looping statements. And that just sounds so simple. And it is fairly simple, but we've got to kind of wade into the deep part of the swimming pool here to get this. So before we get into control statements, we have to understand Boolean expressions, and here's why. We'll use Boolean expressions as the test for the control statement. So that is why we have to get into this part. So Boolean expressions are simply expressions that evaluate to either true or false. Like a light switch, it's either on or off. Okay, it's a very simple comparison. Okay, so we compare A to B. Is it equal or is it not equal? That's a simple Boolean expression. Okay, so you use these expressions in both if statements and looping statements. Python will evaluate the Boolean expression. It's going to return either true or false. And then that value, okay, true or false, can be a variable. Therefore, we can use it in our program if we need to. We don't have to, but we can be. The value can be assigned to a variable. When you're coding Boolean expressions, you need to make your expressions compare numbers with numbers and strings with strings. This is what I was talking about a minute ago. Okay, kind of got off on something. And this is important. So if you compare a string with a number, it's not going to do exactly what you think it's going to do. If you compare a number with a string, it does not cause an error. There is no error, okay? What's going to happen is the result's not going to be right. And you're going to be looking at your output. You're going to have maybe some runtime or logic complications that you don't know what's going on, and there's no error. That is going to be data type. We're going to have a data type situation. So just keep in the back of your mind all the time when you're coding, am I using the correct data type? Data type is a curse for programmers, okay? We have to be on our toes. We only have 3 that we need to worry about: integers, float points, and float values, and strings, okay? So just make sure that you're always thinking, okay, is this the right data type? Do I need to run it through a function to change the data type? Okay. And once you kind of get used to doing that, it's not so bad. So if you compare a number with a string, the results are going to not be good. Okay. If you compare an integer with a float point, they're both numerical. Okay. So you probably are going to be okay. Those 2 data types will probably compare okay, because an integer and a float point, the main thing that's different is the decimal places in the float value. So we are fairly consistent there, but comparing a string to a number is never a good thing, ever. So when you use the equal to operator, it's not the same thing as the assignment operator. They look similar. We talked last week about the assignment operator, ABC variable equals sign, the assignment operator equals something, okay? A single equal sign is an assignment operator. An equal to operator used in a Boolean expression is 2 equal signs. And if you use a single equal sign, you're going to have a problem. You're going to get a syntax error because it's not assignment. So just remember, when you see 2 equal signs, that is the equal to operator, and you're probably looking, you should be looking at a Boolean expression, okay? Now, another tip, and our book does a good job of giving us tips or suggestions or best practices. And this can be a problem if we don't kind of absorb these. You know, these are things that you can learn through hard knocks, but we don't have to learn them that way. Realize that it is just not going to be good for us to either do an equal to, and there's also a not equal to operator. We can't use those on float points, floating values, because of that itty bitty remainder that we talked about last week that's always going to be nagging us in a true floating point value. Okay. So the answer to that question is to use the greater than or less than operators. And we have examples coming up. Okay, another sidebar here. This is not, your eyes are not going out on you. This is not an eye test or a vision test. I hate this, but this is another transparency issue. I want to be totally upfront with you. When I put together the slides for this course, I used the ebook edition of our book from Murac, okay? And I did a bunch of cutting and pasting, okay? And that's the fastest way to get a set of slides put together, because this publisher did provide some slides, but they were very basic. They didn't really do everything I wanted them to do. So I'm stuck with the ebook. Well, there are certain pages and certain chapters that they didn't have, whatever they used to scan the ebook, they didn't have it focused right. And I've complained to there's actually a vendor that it's called vitalsource.com. If you've used them, Vital Source, I complained to them about this. I also complained to Murac, and I haven't hit the right person yet to get this fixed. I checked on this earlier this week on this particular chapter. It's so important that we get this right. And the problem is some of my slides are going to be out of focus. I apologize for that. I wanted you to know why, okay? So it's not something I took lightly. So on slide 7 here, we have the relational operators. I'm going to call these the Boolean operators, okay? It helps me remember where we use them, okay? So textbook, it calls them relational operators. And you see the 2 equal signs is the equal to operator. So returns true if both operands, that means on each side of the operator, if they are equal. The opposite of that is the not equal to, which is an exclamation point and an equal sign. It returns true if the left and right operands are not equal. Okay, so we can go either equal or not equal. Greater than and less than, I think you guys can figure that out pretty easy. And then the greater than or equal to, or the less than and equal to operators, you're going to use those a lot with float point values, okay? So we'll see examples. Some of them are going to be a little fuzzy. Here's another look at the operators in focus. I got this from a different source. This actually came from the slides that Murac gave me. So whoever did the slides had the same problem I did with them being out of focus. So also on that same page in our ebook were some examples of these relational operators, these Boolean expressions. And you guys can see this in your books, and it probably will be in focus. I hope it will. So we see age is equal to 5. That is a numeric literal, okay? And first name is equal to John. That is a string literal. And we have the not equal to and the greater than and the less than. And notice that those we are dealing with numeric values, and we can, that less than is kind of interesting. The fuel underscore reg is less than fuel underscore cap. That's probably going to be a numeric value. You can do a less than in strings, but that's not in this chapter, so let's don't talk about that. So greater than or equal to or less than and equal to, we have examples of that. And then the last Boolean expression there, the rate divided by 100, that is mathematical. Because we are dividing, the chances are there's going to be a remainder, a decimal point there. So we go ahead and put that into a relational operator, send that to a relational operator, which is greater than or equal to 0.1. So that is a numeric comparison there. So just realize that these Boolean expressions, all of this, because they're Boolean expressions, are going to either be true or false. So is the age equal to 5? Is the first name equal to John? Is the quantity not equal to 0? Think of it like that, because the value of the variable is going to be true or it's going to be false, one or the other. So now let's ramp it up. Now that we know what relational operators are, we can get into logical operators being used in compound conditional expressions, okay? You're going to have lots of examples of this. You probably studied this in other classes. And normally these operators are capitalized, but they don't have to be. So we have the and operator and the or operator. So we can have a Boolean expression and or and a second Boolean expression, a Boolean expression or this Boolean expression. And so just realize we are compounding a conditional expression. That means we have to have two, it's weird, it's backwards, two or more. Well, we're going to see examples of more, but let's just start off with two. So in an and situation, when you're using an and compound expression, both of the expressions have to be true. A has to be true and B has to be true. Or is the opposite of that. If A is true, we won't even look at B because we can move on. But if A is false, then is B false? If B is true, we're good. If it's false, then we have a problem. So realize that or returns true if either of the expression is true. And just realize once it hits true on the first one, this stops. That's the end on an or. There's one more. It's called the not operator. And the value here is returned by the expression. It's going to be reversed, okay? So not operators are evaluated before and operators, which are evaluated before or operators. There's that precedence again. Not comes before and comes before or, okay? So if we want to change the logic, flip the logic, students hate questions in tests which have the not operator in them. You can actually use that in language. Which of the following is not one of the 5 things that you have to do? So now you got to know a lot of stuff to answer that question, because you got to know 5 things, and I got to pick out one of these that's in this test question that's not true. You know, that's a not operator. So that goes first. And then we have and operators where both sides have to be true. And then or, which is the most forgiving, either side can be true. Okay, so I think it makes sense if you think about the fact that not is going to flip the logics, basically reverse the logic. Now we can control this order of operation. That's another way to say it, order of operation, order of precedence, with parentheses, just like we can do in math. We studied that last week. So you can use logical operators to join 2 or more Boolean expressions. Now we get into compound conditional expressions that are more complex, okay? Now, a little sidebar here. You don't have to use compound conditional expressions every time you have the opportunity. There is normally a second way to code this that does not involve compound conditional expressions. We'll see some examples of that in Unit 3 here, okay? So the order of operation, the order of precedence here determines the sequence in which those logical operators are going to be executed. We can use the parentheses to clarify. I like that, clarify or change the sequence. And we know about the and or the ors. Now, it's interesting, and this is actually a term in the chapter that's probably going to be in a question somewhere. The and the or operators only evaluate the second expression if necessary. As soon as they see a true, it's over with, okay? True is true, move on. So that is why it's called a short circuit operator. I have never, ever seen that anywhere except in this book, but it must be a real thing. So short circuit operators are and or operators. The second part of this, and notice this one's in focus now, this page, this table, the bottom part here, the order of precedence. I like order of operation. How they operate from not to and to or. Just remember that order, okay? And I think we pretty well covered the definition of these, but there it is in your book and in the slides if you need it. Let's look at some examples of what we're talking about. The and operator. If the age is greater than or equal to 65 and the city is equal to Chicago, true. Notice it has Greenville and South Carolina here. That is in our book. I didn't make that up. That's interesting. They have good old Greenville, South Carolina in our textbook. The textbook was written in California. I don't know why they picked Greenville. So the or operator, city is equal to Greenville, or the age is greater than or equal to 65. Okay, if the first one's true, ball game over. If it's not, is the second one true? Okay. The not operator flips the logic. Age is not greater than or equal to 65. Then we can have a bunch of operators. Here's two and operators. Age is greater than or equal to 65, and the city is equal to Greenville, and the state is equal to South Carolina. So we had 1, 2 ands in there to make that a much more complex compound expression. 2 or more or operators, okay? So if one of these is true, we have a match. So is the age greater than or equal to 65, or the age is less than 18, or the status is retired, okay? So you see how that flows. As soon as it hits a true in those 3 conditions, then we have a true. We're looking for a true. The thing about an and is they all have to be true, whereas the ors, the first true wins. Now, the last 2 show changing the order of precedence, and or change the order of operation by using the parentheses. So inside the parentheses is going to happen first. So age has to be greater than or equal to 65 and status has to be retired. That has to evaluate to true, or age has to be less than 18. That could be true. So this whole thing has to be true, or this has to be true. And we can mix and match. We can have an and an or with parens, or change their sequence of operations. So age is greater than or equal to 65, and now one of these things has to happen. Status has to equal retired, or state has to equal South Carolina. How about that? So these are fairly logical. That's why they're called relational operators. We can understand how they work. We can understand how they fit into a compound expression there. And we can do a lot of programming with that. Any questions about these guys, these logical operators, the relational operators? Okay. I don't know why I'm doing this. Just kind of flashing it on the screen there, get everybody awake this morning. Let's move on to something else. And this is something that you will run into. You're thinking, oh, this will never be a problem. Yes, it will be. First thing, when you compare 2 strings, it compares character by character from left to right. So when you do a string comparison, the actual words mean nothing. It's the characters that mean everything. So here's the point of this whole discussion in this part of the chapter. Digits are always sorted first, come first, then uppercase letters, then lowercase letters. So digits, uppercase, then lowercase. That is the way our computers work, whether they are Windows computers, Unix computers, Mac computers, they all are consistent on this. And so it's not just Python. Python didn't invent this situation. So we see it in programming when we compare character by character. Now, one way that you can see this on your computer is look at how the directories sort in Windows 10, the folders titles, the names of your files and your folders sort. They follow this: digits first, uppercase next, then lowercase. And if you look at my folders, they're all mixed up. And so that's not good. But you can develop naming conventions for your organization based on this. So anyway, we got to understand that sort sequence. If you remember that, you'll understand why lowercase peach, P-E-A-C-H, comes before pear, P-E-A-R. Because at the fourth character, going character to character, left to right, they are all lowercase, so we don't have that problem. But at the fourth character, C is lower than R. So peach will come before pear. And if you look at the bottom bullet here, peach with an uppercase P will come before apple with the lowercase a. Well, P is higher in the alphabet, should be lower in the sort, but that's not the way it's going to happen based on the natural behavior of character strings. Okay, so try to keep that in the back of your mind, and that takes us to our upper and lower methods, because we know this situation can happen. So as programmers, we have to defeat this. And the lower method and the upper method are kryptonite to this problem, okay? They will force the issue. And most of the time, you're going to see programmers use the lower method and convert strings to all lowercase when they do a comparison. Then they don't have to worry about that, okay? So the syntax for using the lower method or the upper method is a little different than what we saw with functions. So this is another way that we can see a subtle difference. Okay, so we have the variable name, XYZ variable, a dot, then the name of the method that we want to use, lower or upper, then the parens, and then the data inside that method. Okay, inside that parameter for that method in the parentheses. So I think this is kind of a review here. When we evaluate strings from left to right with numbers coming before letters, uppercase coming before lowercase, and then you call the method with the variable name, a dot, the method name, and then the parentheses. Inside the parentheses is going to be the parameter, which is going to be the text that you want to convert, the letters. Okay, it's really, to the method, it's just characters. So here's some basic string comparisons using the then remember I said you could use the less than or up or more than, greater than operators to compare strings. So lowercase a apple is less than uppercase a apple. And notice it evaluates to false, because when we're using these relational operators, it's always going to evaluate true or false. Okay, this is all that Boolean mess that we're talking about. So it's because that uppercase A is the last to be sorted, okay, by default. Therefore, we get a false Boolean result. So uppercase A app is less than uppercase Apple with the uppercase A on Apple. That's true. Okay. And then we get into numeric. That's super easy. Now, understand that we converted these to strings with those quotation marks there. So that string 1 is less than string 5 and string 10 is less than string 5. So you see how that works. These numbers are changed to strings because of the double quotes on them, and we're going character by character left to right. So there's actually no difference in this comparison between 1 is less than 5 and 10 is less than 5 because it's comparing on the first digit of the two values on the side, each side of the relational operator. Isn't this fun? Oh man, I can see your hair's on fire out there. Be careful with that. Okay. So I think we kind of covered these methods. Just keep these in your mind. You're going to use them every week. You're not going to get away from these guys. Everything in Unit 3, you're going to use every week the rest of the way. Syntax to use a method. Okay, this is the string method, variable name, dot, the method name, and then whatever we're changing case on. So string 1 equals Mary with an uppercase M. String 2 is Mary with all lowercase. And then if we use the equal to operator, Boolean expression, string 1 equal to string 2, we're going to evaluate to false there because of that capital M, okay? So if we run these through in the third example here, let me cut on this guy. The third example here, fourth example, okay, I can't count. We run the strings through the lower method, okay? And now that equal to is going to come out true because that negated, that was kryptonite to that uppercase M there, okay? Then we can go ahead and print the strings. And notice when we print the strings, we have done nothing to the strings. All this method did was change the object to lowercase for evaluation purposes only. Maybe that will help you understand that part of this. This is just for evaluation purposes. Now, if we wanted to change it again down here in the print statement, we could, but that's not what we're doing in this example. Now, this is, these two pieces of code here are actually the same. But what we're trying to show you here in this last little example is how to use the method to make this cleaner, okay? So we're using the OR operator. Notice it is lowercase here, but we're saying customer type is equal to lowercase r or customer type is equal to uppercase R. That's, we're trying to handle the case there, all right? Well, why don't we just do customer type dot lower equals R, and that solves the whole thing. We just run it through the method there and see how we handle that method. We left the method empty there and just said this has to be lower. Whatever this value is has to be lower. So you're going to see lots of examples of that as we go through here. All right, so that was just the first third of the chapter. Now we're into the second third, going through selection structure. I think that maybe another way to say this is decision structure. Decision struction. Gosh, got up too early this morning. Decision structure. Thank you. Decision structure is the same as selection structure. We're making decisions. We're making selections. We're selecting options. That is what we use the if statement for. Okay, very common in most languages. So if statements, whether it's in Python or C# or something else, if statements need a Boolean expression to evaluate. So they need to know whether the if statement is true or false. We're just trying to evaluate true or false. Okay. So the first part of an if statement is an if clause. I know that is splitting hairs, but we've got to talk like programmers. So an if statement starts with an if clause. And inside the brackets, when you see the syntax following the if clause, you could have some else ifs, okay? And else ifs means, okay, if the first selection evaluates to false, let's take a crack at else if and see if that evaluates to true. If that doesn't evaluate to true, let's have another else if, see if that evaluates to true. And I'm running out of options here. So the last one's going to be an else clause, and that's going to be the last resort. Whatever, if it gets through this whole structure, if whatever we're evaluating gets all the way to the bottom, then the else clause kicks in, and that may be an error message. You'll see a lot of examples where that's an error message to the user. So when we code an if clause, okay, if is the key word. We code loops, it's a little different. Okay, so we're talking about coding if statements. If is the key word that starts this whole statement. It is also a clause. Okay, it is to be followed directly after the if with the Boolean expression. Does A equal B? Whatever it is. Okay, something to evaluate to true. And then here's the Python thing in the syntax, because this is not the same in other languages, followed by a colon. That is Python. Python always terminates the if clause with a colon. Now, the other Python thing is the block of statements that need to be run if the Boolean expression is true are indented 4 spaces. I know it could be more than 4 spaces, but let's just say 4 spaces to be consistent. So then you code a block of 1 or more indented statements, okay? Once that indentation stops, okay, that's the end of the block of code, also called a suite, you'll see here in a minute, which I don't like that word. I just won't call it a block of code. That's what everybody calls it, okay? And then after that block of code, then we can have an else if statement or an else statement or clause. Let's talk the talk. An else if clause or an else clause after the block of code. And in the else clause or the else if clause, those are the key words, else or else if, ELIF for else if. You can have another block of code. Needless to say, that's the whole point of the selection statements, to have a block of code. So let's take a look at how this works. Yeah, I know the block can be called a suite. Who cares? I don't like that. All right. It's one of those words we're going to have to remember, at least for this course. I'm sorry. So here's the syntax statement showing us how an if statement works. So to repeat, because we're learning this for the first time, if is a key word, if is a clause, then there's going to be a Boolean expression that has to evaluate to true or false, okay? We're going to terminate that first line with a colon. That's the Python thing. We're going to drop in 4 spaces and have some statements here that will run only if that Boolean expression is true, okay? If that Boolean expression is false, then the logic is going to go to the optional, because it's in brackets here, the optional else if statement, else if clause. And we have another Boolean expression if we want to, okay? And then we have a block of code. Remember that else if has to terminate with a colon. And we don't have to have this. We could, probably will, but if we have an else if, we're going to have an else, okay? And the else is going to be the final block of code. You're going to learn from examples and from actually doing this. So that's what we're going to see now next. 3 different examples to show you how these clauses work, okay? So first off, a straight if statement. If age is greater than or equal to 18, it has to evaluate to true to run the block of code. Well, this is a 1-line block of code here, a print function you may vote. That is a simple if statement. There's so much you can do with just a simple if statement. I love them. Now, an if else statement, okay, if age is greater than or equal to 18, colon, print, you may vote, else, colon, notice we didn't have any more Boolean expression there because we're going to run the else if, the else clause based on the fact that the if statement was false, okay, then we'll print you're too young to vote. Now, here's an example where the else if will have a Boolean expression, okay? If the invoice total is greater than or equal to 500, colon, then the discount percent is going to be 0.2. So this has to be true, then the discount percent will be 2.2. Else if, now here's another Boolean expression, if else if the invoice total is greater than or equal to 250, then if that evaluates to true, then the discount percent will be 0.1. We got yet another option. Else if the Boolean expression invoice underscore total is greater than 0, colon, then the discount percent is going to equal 0. Else, notice there's no Boolean expression here, just else, colon, print invoice total must be greater than 0. Now, here's some best practice. Here's some stuff that is covered in the chapter. Your first option, your first selection, the first decision that you code should be the most common, okay? Now, this is a numeric problem here. And so in a numeric problems, typically you go from the larger number down to the smaller number. Notice here we're going from 500 to 250 to 0, okay? So we're trying to calculate a percent of a discount, as you can tell. So we go from the one that will hit on most of the time or the largest number, then go to the next and the next and the next. We have a logical progression. And notice how else, if nothing matches up, there are no trues, then we have what equates here to a kind of an error message. Invoice total must be greater than 0. Now, let me make this very clear. I love to tell users what's wrong, okay? How many times, this happens to me almost daily. It happened to me yesterday. I was debugging something on my phone, got so frustrated because the app was not telling me what I was doing wrong. So try to be nice to your users. Tell them when they're doing something wrong. Give them a chance to fix it. And that's what we're doing in this else, if, else statement here in this bottom example. True story. So sometimes in my notes, you will see that I just cut and paste the kind of summary at the end of the examples out of our book. And because this is so important, we have to learn these control structures. Here's kind of 5 bullet points we should just pack away in our brain and never forget. I'm going to let you read these. I'm not going to read them to you again. I know you're getting tired of me reading to you. So just pay special attention to these when you study in your textbook. Some more examples of if statements, and they're going to get a little bit harder. When you code an if statement, you try to make it as easy to read as possible. That's what I was saying before. Just remember, you got to go through code reviews as a professional programmer. As a student, you got to go through teachers that are going to review your code. So document your statements, document your code so that whoever's reading it knows what's going on. And then when you, in this case, write an if statement, make sure it's easy to read. And even if I mumble, I'm still reading. The problem is my brain gets ahead of my mouth and then mumble out. So you know how that is. Maybe not. It'll happen to you when you get old like me. So avoid the use of the not operator. That flips the logic. Not a good idea. Don't do it. How negative can I be? So that just makes it hard to follow logically. This means you may sometimes need to use a past statement. My least favorite thing to use is a past statement because all a past statement does is nothing. It is just null and void, okay? So you may have to use a past statement if you use a not operator. So don't use past statements and don't use not operators. So for efficiency, you may want to start by coding the conditions that are most likely to be true first and end with the conditions that are least likely to be true. That was what I was saying a minute ago. So if statements are often used to choose one option out of several, duh. Okay, that's exactly what we've been talking about. There are times, and you're going to do a lot of this if you're going to be a good programmer, you're going to use if statements to validate code, to validate data that's coming in from your user. And users will not follow your directions. Users will not read what's on the screen. So you have to be diligent and monitor what your users are inputting into your program and make sure it's in the right format, whatever it is. This can be easy, super easy, or it can be difficult depending on what you're doing. And you can always tell, and I don't know, the more programming classes I teach, I get more critical of commercial software. But you can always tell when the programmer was in a hurry or they were just all about show and not about substance. But if you run into a program that doesn't validate data, be warned. That's not a good program. There could be a problem. So, you probably already know that, but it just irritates me when programmers do a crappy job. The past statement does nothing. We talked about that. And if statements can be coded different ways. And we're going to see some comparisons right now. And once again, a little bit fuzzy out of my ebook. So here's an if statement that's used for grading. Remember, all of the if statements are Boolean expressions. We're just looking for true. Now, in this whole if statement here, this whole control structure, all we're looking for true. All we want is true. Once we hit true, game over. We don't go any further in this statement. So score is going to equal an integer that is input from our user at a prompt that says enter test score. Notice we have two functions that are embedded. A lot of that in Python. So integer embedded into, well, actually it's the other way around. Input is embedded into the integer function here. So we have a whole number. We're not dealing with any fractions of any kind. So if the score is greater than or equal to 90, grade's going to be an A. Else if, next possible thing could be is a B, right? So we'll go to a B. Else if, well, let's say it this way, if it's not equal to or greater than 90, then is it equal to or greater than 80? If it is, then your grade is a B. Once again, we just keep doing the same thing as we go through C and D. And if none of those are true, there's only one thing left. If you don't have an A or B or C or a D, you flunked. You get an F. And that is a beautiful example of a simple if statement that is written as actually an if else statement, and it's written using integers. Here's another way to do the same thing, a little more complicated code. Now, I said this yesterday in class. I don't know if anybody really cared, but notice that in this example, and if you have a good teacher that gives you bonus points or, maybe a curve does it. So if the score is greater than or equal to 90, what about 105? Maybe you had 110 on the score. This will work. Notice in this next example, if the score is greater than or equal to 90 and it is less than or equal to 100, then you get an A. That is a range. It is establishing a range because of the and operator, okay? We have two basic Boolean expressions here that are ANDed, okay? So there goes my 105 example, because it's not going to answer true here. We got a problem. This is going to throw an F if you make 105. Think about that. It's going to evaluate to F. So grade A, then our else clause, if it's 80 to 90, okay, then it's a B, 70 to 80, C, so forth and so on. If it doesn't hit true, it's going to be F. Well, 105 is not going to evaluate to true in any of these. So be careful. I'm disagreeing with the book here a little bit, because these are not exactly the same logic, these two comparisons. There's a little bit of difference there. And just another footnote, Blackboard uses this logic, okay? I'm glad that it does, because it gives me the ability to have students make more than 100 points on an assignment or a test. But if it was like this, which Moodle uses this logic, if you get any bonus points, it's going to have a problem. It's not going to evaluate right. All right. So as I said, we created a range when we use that AND operator. And so here's another way that we could just accumulate scores, okay? Actually, this is validation. I should read the slide before I start talking. This is data validation. And for that second example, this would be good data validation. If the score is greater than or equal to 0 and less than or equal to 100, then add that score to the total. Remember this operator from last week, plus equals. So that is a compound operator. It just adds score to total score. Then our else clause, we print test score must be between 0 and 100. That's the data validation part. So this is good. This gives you an example of validating a range. And this is just another validation of customer type. So what we are supposed to be seeing here is a combination of what we learned last week plus this week to have more productive, more professional code. So we have a variable named is_valid, and we're going to set it to true. We'll start off true. So that means we are going to leave it true until we hit a false, okay? So customer type is going to be input here is either an R or a W for retail or wholesale, okay? Just a simple input. If customer type is equal to R or customer type is equal to W, pass. I hate that. That means there's a missing block of code here. This statement does nothing. Else print the customer type must be R or W. Is invalid is turned to false at that point. Okay. Yeah, that validated the code. But what's the problem here? It didn't take into consideration uppercase. So what if somebody's trying to do a really good job on this input, one of your users puts in a capital R or a capital W? That is going to throw the error message, and it's just going to annoy the user. So we should have used a method to change the upper or lower method, in this case, lower method, to change that object to lowercase. Object oriented. Notice how I slipped that in there. So in many programs, you're going to need to code one if statement within a clause of another if statement. That is very common. This is not unusual, nested if statements. So if this is true, then let's go down this rabbit hole. If it's not true, let's do this. And you can see how this works. So I don't know. We deal with nested if statements in our everyday life. We just have to think logically, use common sense, and there can be lots of situations. So here we're doing nested if statements, a little bit fuzzy, out of focus, I know, even to the point that we had to create a table at the bottom here that shows us what we're trying to do in this control statement, this if statement, this if else statement, the different ways you can describe this. So this is the correct way to program what we were talking about. If the customer type is, let's go ahead and change it to lowercase r in case somebody inputted an uppercase r, we still want to do the work for them. If that is the case, then let's run this if statement and calculate the discount, okay? Else if, because if this is false, then we still have to change that W to lowercase, be consistent here, keep that customer type lowercase for this evaluation. If well, you can just see it here, it's a different set of discount rules for a wholesale customer, and else the discount's just going to be 0, because if you're not an R or a W, no matter what the case is, you get no discount. I'm wondering if there should not be a print statement here at the bottom that says something like, your discount is going to be 0 because you are not a retail or wholesale customer, something to make the user of this particular program understand what's going on. So let's consider some alternate ways to code if statements. And this one is going to do the same thing as the previous code. This is option A. Is this look in focus? Okay. This is option B. We actually have an if statement in our discussion here. Okay. So this is a second option, a second alternative to do pretty much the same thing. And we're doing this with compound conditional expressions, compound conditional expressions. So if the customer type running through the lower method is R and the invoice total is less than 100, then the discount's going to be 0. And that's evidently where most of this is doing. So we're doing this kind of in reverse here. So if it's between 100 and 250, it's 0.1. If it's between, or if it's greater than or equal to 250, it's 0.2. So those are retail customers, got this nice documentation here. For wholesale customers, same idea, different discounts, and then our discount down here 0 if you don't match up here. If all this evaluates to false. Notice by using compound conditional statements, we did not have to use nested ifs. So there's your yin and yang. Either you use nested ifs like we did here, or you're going to have to use compound conditional logic to do two things at once in your lines of code here to get it to work. So I hope that makes sense. And that's basically what this explanation says. So look at the last bullet here. It is debatable as to whether the second if statement is any easier to read than the first. Absolutely, that's debatable. But if the first example included comments and like the second statement did, it would probably be easier to read and maintain. I agree with that. So they're saying this is easier to read, this is easier to understand in a code review than this. This is more complex, certainly a lot more room for error in this. So I agree. And let me just put this one other way. Nested ifs are okay. They're a good thing. So use nested ifs if it comes up. Little pseudocode, just a little glimpse at some pseudocode here for what we were doing. And so as whoever was designing this little program was getting ready, they scratched out on a piece of paper, if the type is R, then run this if, nested if statement. And if it's W, run this statement, else print this invalid type message. So that is a good example of pseudocode. Yeah, it's just common sense. It's not real formal. You know, some people go to great extremes as they write pseudocode, but at least all of us in this class should be able to scratch it out on a piece of paper to help us stay focused. Here's another example of an if statement on the test score program. You can see it does the same thing, just kind of sketching it out. Notice we are good Python students, and so our blocks of code in the if statement up here in the pseudocode are indented. I thought that was kind of cool, trying to maintain that idea of indentation. Okay, so here's a miles per gallon program to show you how to use if statements, and a little more practical example. So the output to the console with invalid data, and we always want to test with invalid data before we put it in production. So you can see we have the title here for the program, enter the miles driven, 150, enter the gallons used, 0. They were running on air, evidently. So we got an error message here. Gallons used must be greater than 0. Please try again. We're being very polite there. That's very nice. Then with valid data, we actually put the gallons in, we got a result. So just realize that to be a good programmer, we want to be helpful with our error messages, and we want to be polite. Always be polite. Doesn't hurt to be polite. All right, how long have we been at this? We're going to be running over today for sure. All right, so here's the code for the miles per gallon program that we just looked at. So the display a welcome message. I love the documentation. Here's the print statement for the beginning, the welcome. And then we're going to have input from the user. And so we're just collecting 2 floats. Okay, we know they're going to be floats. So we go ahead and embed the input inside the float to get what we need. Okay. And then actually we need a documentation right here to explain what we're doing. So here's our data validation part. This is the data validation, and then this is the actual math down here. So please put some documentation, even inside an if statement you can document. So if miles driven is less than or equal to 0, then print miles driven must be greater than 0. Please try again. Else if clause, gallons used is less than or equal to 0. We saw this one in action in our example. Else, now we get to calculate and display the miles per gallon. So that's a good example of putting a documentation line in a block of code inside an if statement. And so there we are calculating and rounding, because it's a float, miles driven divided by gallons used. And notice that we want to do this math. Notice the use of parentheses here. We want to do this math first. We want to take it to 2 decimal places in the round function. And then in our print function here, we want to, and actually notice the spaces we built in here to make it look pretty, miles per gallon. And then we want to line up and just regurgitate the miles per gallon here, the MPG. No, yeah, based on what we learned last week, we could write this 2 different ways. This is a way to do it. So this is a string, and this can be a float because we stopped the string right there. So this can be a float. This is actually an easy way to do it. Then a blank line and by, because we are polite. Okay, another way that the if statement could have been done using a compound conditional expression. And so our if has 2 checks here. If the miles driven is greater than 0 and the gallons used greater than 0, then go ahead and do this. Otherwise, print both entries must be greater than 0. Please try again. So that's a twofer kind of deal. I'm with the writers. I think you should do one thing at a time, use a nice, well-developed if statement. But this is another way to do the same thing. The invoice program also used to calculate those discounts we were looking at. So let's see it in action. We have the name of the program. Actually, the The miles per gallon is lab 1 this week. The invoice program's lab 2. So you can see we're going over these to help you with your labs here a little bit. So the invoice program heading or welcome is there, a blank line. Then we have to declare our customer type. Notice we have an uppercase R there because we want to use that lower method to change that case, and then enter the invoice total, 250. So we go through our if statement to figure out what the discount's going to be. It's going to be 0.2 because of that R. And so there's our discount amount, and there's the new total after we subtract it. So a nifty little program that could pop up in somebody's screen so they can calculate a discount on the fly. So let's look at the code. This is going to be a Python 3 program. There's our shebang. We learned that last week. Display our welcome message. We know how to do that now. Get our user input. And so notice here, we're just going to accept whatever they're going to do here, either an R or a W. Got some tabs there to line it up. And the invoice total is going to be a float. So we embedded the input function inside the float here to get that value. And then we want a blank line. So that just gave us our 2 prompts and a blank line. And now notice the nice comment there, the documentation. And we are using a nested if statement structure here to do this. Beautiful code, easy to understand. So if the customer type, we want to run it through the lower method is equal to R. So that'll take that big R and make it a little R. And then we go into the nested if here. So if, else if, else if, else if, and that's all inside the if statement. And we don't want to break out, so we didn't run that else clause. We just ran else ifs. Okay. And then another comment here. Then we have an else if in the outer if statement, okay, which takes care of our wholesale customers. And then we set 0 for any other type of customer, which we have seen. Okay. So that's the nuts and bolts of the program. And then we just do our math here. Okay. So calculate the discount. Oops, I cut my circle off there. Calculate the discount amount in the new invoice total. So do some simple math here, rounding off the float point to get it to 2 digits, and also come up with the new invoice total. So invoice total minus the discount amount. Display our results. All this is just print stuff. We know that real well now. We're converting our float points to strings so that they are nice and pretty on the screen. Blank line by. So there you go. That is lab number 2. All right, iteration structure. As you may have already assumed, I said repetition structure because that's the way I learned how to do this. So iteration also means repeat or repetition. So we're on the same page here. Very common, very important that we understand these next 2 control statements, okay? So we're going to test for a condition. That's going to be a Boolean expression. We're going to either count possibly, or we're going to test for an expression. And then while that expression returns true, we're going to do something. And then when it turns false, we're done. Okay, so that's why it's called an iteration or repetition structure. And we have 2 ways to do this, with a while statement or a for statement. And we use a lot of both of these. There's 2 different reasons for using them. We'll look at a while statement first. And I'm going to give you a good example of why a while statement is important. You're going to see examples of this before it becomes apparent. But in our programs that we run in the console in Windows 10 or Mac OS, if we don't run the program inside a while statement, that console is going to close as soon as the calculation's finished. The user is not even going to be able to read the output. So we have to put an outside loop on our program to hold that console open. So we've actually seen examples of that. Continue, yes, no, all of that stuff. That is going to become abundantly clear here as we look at while loops. There are other reasons for using a while loop, but that's one we'll use a lot. That's number one. So while the condition is true, whatever it is we're looking at, run the indented block of code. So the while statement, just like the if statement, is going to include the while keyword, then the Boolean expression, then a colon. Then it will run the block of code. We're not even going to use that sweet word we learned. So while the statement is true, run the code, go through the loop. That's considered a condition control loop. Okay, so it's an iterative structure, a repetitive structure. It's a while loop, while statement, okay? And it's also called a condition control loop. All the same thing. Give me a gun. No, don't do that. It's just we got lots of names for the same thing. And unfortunately, as students in a college of knowledge, we have to learn all these different words. So if the while structure, the while statement does not ever evaluate to true, you have an infinite loop. You also get a nasty gram from your teacher. Infinite loops are not a good thing. Now, one of the students that caught something wrong on one of our quizzes sent me an email this week, said, this is an infinite loop. There was a mistake in the question, but it was not an infinite loop. So, if you see any problems with any of the questions in the quizzes or lab doesn't make sense, you need to tell me, because you may see something that is actually wrong that hasn't been detected yet. And I want to change what I can change in our quizzes and our labs so they work right. So anyway, so far we've had a couple of questions that we had to adjust this semester in the quizzes. I think I already mentioned that. So infinite loops are a bad thing. Oh, fuzzy. Here's another fuzzy page from the ebook. Okay. So the syntax for a while loop's very simple. While this Boolean expression, colon. Whatever it is, super easy. So here's a good example of what we're talking about. Very simple little program. Choice is going to be set to Y. This is an assignment operator. Set that to a string Y. While choice, go ahead and run it through the lower method using this syntax. Just run this value through the lower method is equal to Y, then do this block of code. Print hello, choice, input, say hello again, yes or no. There's the prompt to go through the loop again. If I say no, then it will say bye and break out, because then choice rather becomes in, and that'll break out of the loop. So real simple example of what a while loop does. We're going to see this over and over and over again. We need to practice using that. Another example of things that you will see are going to be counters. Now, there are different ways to do counters. They're not always going to be the same. So just realize when you see some value that is incremented every time you go through a loop, that's considered a counter, no matter what the variable name is. This one is called counter. So we are setting counter to 0, initializing it to 0. Then while the counter is less than 5, okay, and there's the colon, print the counter, change the n to a space, so we space out the results on the screen. And then we want to increment the counter, and we want it to go up by 1. So counter plus 1, this will add 1 to that variable. Remember, we set it to 0. So the first time through, it's going to go from 0 to 1. And then when you go through this loop here, print, and on a, notice the new line character, the loop has ended. Okay, so here's the print when we go through the loop. This is what we'll print when we're done. That's why we have the new line there. I didn't say that very clearly. So our output's going to be 0 through the first loop. 1, 2, 3, 4. It went through 5 times, got up to 4, then the loop ended, okay, because 0 is a number. All right, so simple little while loop. So while true, any statements in the loop will run, and it could go on forever if you do not break out of it, if there's not a way to get to a false condition. So here is my tip of the day, Control plus C. If you find yourself stuck while you're playing around, while you're doing your homework, whatever the case may be, just remember Control C. That works in Windows. They left it out of the book. It works in Linux. It also works in Mac OS. So Mac OS is Command plus C. I don't think they use Control in Mac the way we do. So Command plus C on a Mac or Control plus C in Windows and Linux. All right, now for loop. A for loop is a collection controlled loop, okay? In this case, we're not a condition control loop, we're a collection control loop. In other words, there's a definite number of times the loop's going to run. And we're going to use the range function as a good example. But one thing that is kind of fuzzy in the chapter, probably shouldn't use the word fuzzy, unclear in the chapter, is that you do not have to use a range function with a for loop. It is where we're going to start. It is a good function to use with a for statement. It makes it easy to control, but there can be times when you want to use a for loop to do something that a range is not apropos for, okay? So just realize that's not always the case. And so each time we go through a for loop, once again, we have an indented block of code that we will execute. So there's two parts to a for statement. A for statement is going to execute the loop, and it's going to store whatever is being evaluated in that loop in an integer, that first integer the first time through, okay? So most examples have that as the letter I, which is short for iterator, okay? It could be George, it could be anything, but most examples show it as the letter I for iterator. So that's just a variable that's going to store for a nanosecond the numeric value in our examples here of whatever's going through the range function. It could be whatever is controlling the loop. Could just be a list of numbers that you type in, and it could be lots of things. And this logic, by the way, is very consistent with Bash shell scripting and PHP programming and all of it. So what we're learning here does translate. The syntax is a little different, but the logic is the same, okay? So just realize that that is, in this case, an integer variable for each number that's in the range statement. So a range statement is, we'll want to make sure we understand this. And so let's be careful to look at the syntax for range. So the syntax for the for loop, and let me just highlight this fuzzy output. So for is the keyword. Then we have the iterator. This is a variable, okay, that's going to collect the value. I said two things. There's actually four things if you want to be totally correct. Four things that we have to keep up with in a for loop. So this integer value is just keeping temporarily the value of whatever the range function is doing in this example. In is a key word that is required for loops, okay? And then the range function in our example, and then there's the statements that will be executed. So this range function has to have at least one parameter. If it has just one parameter, it is going to be a number where the range will stop, okay? Now understand this, that stop number will not calculate. It will not run the block of statements. So if you want to go 5 times, you better put a 6 in here for a stop number. Always remember, we got to be 1 up, okay? Now, what if you don't want to use the number 0? which all of the time it will start at 0. Then you could code it this way with 2 parameters, 1 comma 6 for the stop value. And that would go 1, 2, 3, 4, 5. Okay. Now there's a third optional parameter, which is step. So if you want to jump numbers, like do even numbers or odd numbers, you would use step, or every 5th number, or whatever the situation would be. So just realize step is there. It's one of our questions in the quiz, but it is totally optional. So if there's only 1 parameter, it's going to be stop. If there's 2, it's start, stop. If there's 3, it's start, stop, and step. Somebody asked me yesterday, well, what if you just want just stop and step? Well, to my way of thinking, and I have not tested this, you better put a start value in there so these parameters work right. Even if you just need it there for show, could be a 0, but at least that way you know the range function is going to work right. You hear noise in the background. The office below me, where my wife is working, is printing something on our shared printer. All right, so some examples of range. I think we pretty well covered this. So whatever the stop value is will not process. So range 5 is going to go 0, 1, 2, 3, 4. Range 1, 6 is going to be 1, 2, 3, 4, 5. I said both of those. Range 2, 10, 2 is going to start at 2 and do even numbers. Okay, so 2, 4, 6, 8. What if you want to go backwards? Yeah, range will go backwards. Put the start at the top number, the one that you want to start at, which will be the biggest number, the largest number. And then you want to go all the way to 0, but you got to make it go backwards. So you use a -1 to decrement, to go backwards. That's the opposite of increment. The default is increment, but you can decrement to go backwards with a -1 there in the step position or step parameter. All right, so here's an example of a very simple loop again. We actually saw that. I'm not going to go through that. We did that already. Let's move on. We're running over today. So here's a loop that gets a sum of numbers 1 through 4. We're setting or assigning the sum of numbers to 0 here. So 4 is the keyword. I is the iterator. It is the variable that's going to keep the range value. N is a keyword we have to have for for loops. And then range function here. So we'll start at 1, end at 5. And then the sum of numbers are going to increment based on I, whatever that is. Notice we're using this value in 2 places. And that'll work very cleanly. And it will equal 10 because it's going to be 1, because we're starting at 1, 2, 3, 4. We're going to stop before the 5, which is 4. So 1, 2, 3, 4 equals 10. And that's how range function works and how the for loop works. And you're probably thinking that's harder than the while loop. And I'm not going to disagree. I think it is harder, but it has a definite place in programming. And the more you do, the better you're going to get. So we'll keep working on that. So when you use the for statement with a range function, it executes the loop each time the range function changes to a different value. Okay. That is why it's called a collection control loop. Now, there are times in a for loop in particular where you want to break out of the loop based on something. Okay. So breaking out of the loop is done with a break statement, or rather than breaking out, I just want to go ahead and start over again. That would be a continue statement. So in my opinion, there are many more break statements than there are continue statements in for loops, but realize we have the power to do that. Okay. And we'll see some examples of that. Now, it is very possible, just like nested if statements, we can nest loops. And oh, by the way, you can nest loops inside if statements and if statements inside loop statements. And hurrah, that is what programming is. That is why these are called control statements, because we start controlling more complex logic. Okay. So just realize we can mix all this stuff up. That's why we have to write it so it is easily readable. Okay. So that is where the break and continue statements can have real value when you start nesting all this stuff together. And that's where our examples will be. So here's an example of a break. And notice the break happens because we have an if statement here. If data happens to equal exit, then break out of the while loop. This is a while loop, not a if, a for loop, but a while loop. Okay. And so that will cause this block of code to stop, and it'll go to the next line of code, which is a print. It says, okay, bye. You told me to quit, so I am gone. That is a beautiful example of an embedded or a nested if statement with a break statement, getting out of the while loop and doing something good here. It's running a print function for us down here. You'll see that a lot. Continue goes back to the top of the loop. Okay. So another while loop, and we're just calculating what miles per gallon here, doing all that good stuff. And so notice we have that line we saw earlier about how both entries have to be 0, try again. And so they hit the enter key and it continues. Okay. And so remember, I'm thinking about what I just said, whether hitting the enter key will do that. But it'll print and continue to go back to the top. And that's where we're going to get the prompts again. Okay. So what will happen here is it'll go back to the top and it'll get the prompts. Okay. I messed that up a little bit, but you understand what I'm doing. You probably already figured that out. So definitely more breaks than continues in your programming. Another example of a loop here. So just this is a for loop. We want to run this loop 19 times. Okay. For I in range. I is the iterator, N's the keyword, for's keyword, our range function. And this one's going to run 19 times because 20 will not run. Okay. And it'll go through the loop. Notice we're not using the iterator down here anywhere. I is not down in the block of code. That's pretty much what you normally see. In this example, a while loop, while year is 0. Oh, actually, I am initializing the variables, assigning the variable year 0 here, and investment is going to be equal to 10,000. And then while year is less than 20, we're going to do the same thing. So notice you can use a for loop and a while loop for the same situation sometimes. And if you ask me which way I would go here, on this little code, I'd go with a while loop. But a for loop is probably going to be more prevalent, I think. Another example of a for loop here, another investment program, which I think is your last lab, 3-3. We're going to be dealing with the monthly investment program. So, and we'll see this code a couple of times here, but we are entering a monthly investment amount. We're calculating a monthly investment rate. We have an annual rate, have to divide it by 12 for the 12 months. We could calculate on years or months or days or whatever and do the math to get the right time. So here we're just going straight to 120 months, and we're setting future value to 0, assigning it to 0, run our for loop based on the number of months. Okay. And it will go through that loop and calculate the future value. And I'm going to pause to cough here. Sorry about that. We're almost done and I'm still coughing here. So nested loops that get 3, have 3 different test scores and calculate it. Still not my favorite way to do this. Okay. Last week I harped on a good test program, test score program is not going to restrict the number of test scores you put in. And it's very easy to program so you don't have a set number, but we haven't gotten there yet. This is using a for loop with the range function to go 3 times. Okay. 0, 1, 2, 0, 1, 2, not 3. Okay. So I'll go 3 times. And total score is going to equal 0. And for I in range 3, we'll go through this while loop. Interesting. So while true, this is pretty much the same code that we saw last week for entering test scores, okay? But we're going to break here if we get, after we do the total score, so it will give us the total score, okay? If the, if the score is equal to or greater than 0 and compound operator, score is less than or equal to 100, then increment the total score, add to that the score, and break. Okay, come out of the loop, and the total score is going to be printed for you. Okay, and if we don't satisfy this if statement, then we get this error message. Okay, and slow down there just a little bit. Let my coffee kick in. But you see the output to the console here. If we put in 110, we get the error. If we put in -10, we get the error. But we put in 3 test scores here because we're still limited to 3. We get our total score of 190. Kind of a lame program, but that's just kind of showing you how those work. Okay. So the last thing, the last third is real short, last part. And that deals with pseudocode. And I'm just going to let you guys bear down on this when you study. I don't know that I can add anything in the conversation other than just a little observation, but realize this doesn't have to be terribly sophisticated. I think the message here is you have to plan your programs. If you don't plan your programs, you try to code on the fly without any plan, you're going to screw up. I promise you, you will. I've done enough programming to know that is absolutely true. So one way to plan is to use pseudocode. I tend to do kind of an outline form of the program, which is pseudocode simplified even more. The thing about my outline idea is it does not show the logic, whereas true pseudocode will show the logic and data flow. And that's why it's better to use. So this is one of those skills that you're going to have to practice to get good at. Now, for you guys that are programming majors, you're going to have to be much better at this than I am. Because when you walk in for that job interview, how simple is it going to be for that interviewer to say, I want you to write the logic code or the pseudocode for a program to do these 3 things. Go. And hand me the pseudocode on a piece of paper. You don't even have to know code to do it. Pseudocode works with all languages. So, maybe that'll scare you into learning this, because I think for you to be successful in your job interview, you're going to have to know pseudocode. Sorry. So that's kind of my take on it. So here's pseudocode for a while loop. Okay. Display the user message, be nice to them. Then the while loop, while true, do these things, and then print an error message if they don't do it right. We've got the if statement embedded in the while loop. But this is a perfect example of that outer while loop I was talking about to help hold the console open when you run the console without the IDE, okay, when you're using the console to compile. So that is kind of important. I like that outside while loop. This is a better example. This is a better example of pseudocode that actually says that the outside while loop is that choice variable we saw. It could be any variable name you want, but we display a message. We start a while loop. Inside the while loop, we do some work. Inside that work we're doing, we have a for loop. And this is for the future value program. You can read this as good as I can. And then at the end, you have a nice goodbye form. So wrapping up here, the test scores program that I like, this one actually does some work because it's going to take all the little tidbits of test scores we saw and do something meaningful with it. It's going to give you an average. This is something you can actually use. So notice that it has a title and it has a code, for lack of a better, a way to code 999 to end the program, to break out of the loop. You're going to see that, okay? So 999 to end the input. Then I am not limited to 3 here. I can go to all day entering test scores, okay? If I don't enter test scores based on data validation, I get a nice, simple little message that says, that is not a valid test score. Score will be discarded. Try again. I still have all of the valid test scores that I added to the variable that's collecting these test scores. Once I enter 999 for a test score, it's going to give me a total and average them. It's such a good little program, and it's not that hard to do. It's just, well, I got 2 slides of code here. So it is a Python 3 program. Anybody in class can write this. We have our display here. We just call it the test scores program, blank line. Please tell your operators, your users, what they're doing here. So enter 999 to end this input, to stop the program, to whatever you want to call it. They're saying end the input. And then we initialize our variables. We don't have to do that, but we should. That is a good thing. I don't have a problem with that. Then our outside while loop. This is the one that's going to hold the console open while your user uses your program. So now we are going to ask the question to enter a test score space. In the input, we want this to be a whole number. Now, we could do a float point. We'd have to do a little more coding, okay? But right now, we're just going to deal in whole test score numbers, okay? And so that will be a test score. So if the test score goes through data validation here, then we want to add it to the score total. And we want to increment the counter, okay, by 1. Else if the score is equal to 999, break, and that gets us out, and that will end the program and give us our average, our total and our averages. Else if we don't get 999, then we want to ask them to enter a correct test score. Okay, so print the test score must be 0 through 100. Test score will be discarded. You see the code. Actually, that's interesting. They attached 2 strings together there, which is okay. You didn't have to do it. You could write it as one big long string. Didn't notice that the other day. Then we have the next part, which is the end of the program. We're going to calculate the average. So our average score is going to equal round, okay, score total divided by counter. And notice we were incrementing. I'm going to go back one here. We are incrementing our counter right here. I don't know if I said that when I was reading the code a second ago, but after we collect the score total, we're going to increment the counter there. So we can use the counter right here to get the average, okay? And then we finish up here with a nice pretty line, the total score with the score total, and then the average that we calculated here. We already had the total score because we were adding that each time a test score was added. Beautiful little program, super easy, and you guys are going to get up close and personal with that one. Last one, remember I said that the future value program was lab 3-3 this time through, and it's just a little more complex than the test score program, but it's the same structure, the same idea. Once again, Python 3 program. We have our title at the top with the blank line. We set choice to Y. This is a perfect example of why that while loop on the outside of your program is so important. The program starts right here. We start collecting input. This is going to be floats. Remember, we said we weren't dealing with floats with test score. We could have. We did integers. Here we're going to do floats, and you'll see there's a little bit more programming because of that. Ask them for the monthly investment amount and enter the yearly investment rate and enter the number of years. This time we're going to go on years rather than months. And so we have to collect an integer here for the number of years. And now we're going to start converting some of these numbers. First off, monthly interest rate has to be yearly interest rate divided by 12, and then divide that by 100 because it's a percent, okay? And then months is going to be years times 12. 1 year has 12 months. You would think division? No, 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 no. 1 year is 12, so we have to multiply that, okay? Calculate the future value. You've seen this over and over and over. So we assign the future value to 0. We have a for loop here based on the number of months, because if it's just a number of months, that range is going to start at 0 because the last numbers in there does not calculate because we start at 0. Always remember that in range. It's a little confusing to get used to it. So for I, the iterator, in keyword, range, whatever number of months we came up with. So the future value is going to be increased by the monthly investment, okay? And then the monthly interest amount is going to equal future value here times the monthly interest rate that we've already figured out what that monthly percentage is. And then with that, the future value is going to be increased by the monthly interest amount that we calculated right here. Now we've got all our numbers, so we can start printing stuff out. And so now we display the result, future value, some tabs to line it up, convert the rounded value to a string, round future value to 2 decimal places, the round function inside the string function. Remember, prints have to be strings. And then we have to do something with that outside while loop. So we ask the user whether they want to continue or not, so we can set the value or assign the value of choice to whatever value we need, so we know whether to do the while loop again or not. Print a blank line and say bye if they happen to enter no here, and that's the end of the while loop. I love it. Super easy. Okay. Ooh, buddy, I actually really did a good class for you guys. We're way over. So here's a list of terms, a bunch of terms. Notice short circuit operators in here, suite of statements is in here. So all of my favorite terms, plus a couple I'm not too wild about, are in here. But you're accountable for all of these terms at this point. So add those to your Python and programming vocabulary. Also go through the summary. Once again, I put the summary in my notes here. I highlighted in black the key words or the important words. You can kind of see the terms in the chapter in context. Okay, so maybe that will help you. And things that you have to do this week by Sunday, and hopefully you've already started because the week's half over. Read and study chapter 3. Download these slides. I hope they're going to be helpful for you. They're on my website. You have topic number 3 this week. Every week we have a discussion topic. Now, several of you guys in the early unit did not do the replies. Remember, replies count a bunch. So do 3 replies or more to all of those forum posts. And you don't have to do the post and the replies at the same time. You could do your post, just write yourself a reminder to come back and do your replies towards the end of the week. That'll work. And then you're going to have 3 labs, okay? You're going to work on the miles per gallon program, make it better. Then you're going to make the test scores program better. And then the 3rd lab, you're going to make the future value program better, okay? And I hope you enjoy these labs. You might have to do them more than once to get them right. Then you've got your quiz. I think we have the quiz corrected, but if you see any questions that are amiss, let me know and I will fix them. So ladies and gentlemen, do you have any questions? That is our lesson, our class for this week. Q&A time. Just open your mic and start asking if you have any. I'm looking at the chat. Don't see anything. Everybody's quiet. Either I have made you asleep or you're all in the bathroom. I don't know where you are. Hopefully you're here.
A lot of
So
information. No,
there's somebody.
No questions at the moment, just a lot of information to absorb.
You got that right. You have got that right. This is a huge unit. And this is one that you have got to absorb. Okay. Next week is going to be the same thing. We're going to take it up one more notch. So just realize these two, 3 and 4, very important. You have to get these so that the rest of the course makes sense. And I don't know how to say it any other way. So thank you so much for your time and staying with me a little bit over time. I'm going to go ahead and caution you, we're going to have overtime next week too. So other than that, I guess I will let you go. You guys have a great week. Send me an email if you have any questions, and have a good weekend.